Hi guys! This is brought to you by Group 4 Zinc, a grade 12 mutant. We'll now go on further on discussing another arithmetic of chemical solutions, and it is dilution.
Dilution. Dilution is basically the process of minimizing the concentration of a certain solute in a solution by applying more of its solvent. This is an important part of laboratory arithmetic since the amount of concentration of the solutions can hold varying degrees of caution and usage. Keep in mind that in diluting a solution, the solute must remain the same as we add more of its solvent. We can refer to its formula as V sub 1 times C sub 1 equals V sub 2 times C sub 2.
It's quite synonymous to the renowned gas law, Boyles Law, but moving aside, we can see that the initial solution is equated to the final solution. This is because that the amount of solute remains the same before and after dilution. Their volumes and molarities are the factors that changes. Thus, when we divide them, it must be equal approximately to 1. Again, V denotes the volumes of the solution,
C
is the molarities or concentration of the solution. 1 and 2 is linked to either the initial or the final instance of the dilution process.
Now let's look into this example. The concentration of sulfuric acid is 16 molarity. What should be the volume of the acid to make 4 liters of a 2 molarity solution? To process it out, we are given with C sub 1 as 16 molarity, C sub 2 as 2 molarity, V sub 1 is unknown, and V sub 2 as 4 liters. What we need to find is the initial volume. By deriving our formula at V sub 1, the initial volume we plug in the values and cancel out molarities, leaving behind liters. Continuing the solution, we should have an initial volume of sulfuric acid at 0.5 liters.
Let's try this one. To dilute 100 ml of a 50 mg per liter solution to get a 20 mg per liter solution, how much water must be added? We have the given C sub 1 as 50 mg per liter, C sub 2 as 20 mg per liter, V sub 1 as 100 ml or 0.1 liters, as we convert it back later into milliliters as we progress. V sub 2 is unknown. We must get the final volume and the amount of water to be added on the initial solution. Deriving our formula in terms of V sub 2 or the final volume, we get this. Now, by adding our given values and cancelling out milligram per liter, our final unit should be liters. We now get that 0.250 liters or 250 milliliters should be the final volume of the solution. Semantically, speaking of the amount of water needed to be added in the initial solution, we must subtract the final volume to the initial volume at delta V equals V sub 2 minus V sub 1, placing our values on which we know that we must add 150 milliliters to reach its desired final volume and concentrations.
Finally, let's attempt one more shot. What is the concentration of a nitric acid solution if 25 milliliters reacts with 38.5 milliliters of 0.145 molarity of potassium phosphate? Our given values are C sub 1 is the unknown molarity of nitric acid, C sub 2 as 0.145 molarity of potassium phosphate, V sub 1 as 25 milliliters of nitric acid or 0.0250 liters, V sub 2 as 38.5 milliliters of potassium phosphate or 0.0385 liters. We need to find out the initial concentration of nitric acid. We can start by deriving the formula via C sub 1, the molarity of nitric acid. Substituting the respective given value here, we can cancel out the liters of potassium phosphate volumes and also the volume of nitric acid. We are left out with the molarity unit required to be of nitric acid. as we also cancel out potassium phosphate themselves. Continuing the calculations, we arrive at 0.223 molarity of nitric acid, and that is our final answer.
Briefly speaking, we have discussed another segment of arithmetic of chemical solutions. Dilution is the process of decreasing the concentration value of a solution by keeping the same amount of solute and adding more of its solvent. We can refer to the formula V sub 1 times C sub 1 equals V sub 2 times C sub 2. That's all, folks, and thank you for watching.